Okay, hello everyone. All right, welcome to this skills assessment session. So basically today we have a network on my right, very small network. I can see two switches, one router, four hosts, four end devices. So in this network, we're going to be assessed on this. Let me see the objectives. You will practice and be assessed on the following skills: configuration of initial iOS device settings. When we talk of initial device settings, basically we're talking of most of the things that we did in chapter 2. And the stuff that we did in chapter 2, we have, let me see, we have configuration of host names. Okay, just a minute. All right. We have configuration of host names. Where are we in Africa? Yeah. How do you configure host name? How do you configure my passwords? Right, with my passwords, if I user exec, with password yepa privileged, right? We have password yepa my VTY lines. I think these are the past three passwords that we learned. We have also commands which deals with encryption. We have banner. Then which one am I leaving there? I think basically that's it. After that, you save configurations. I think this is chapter 2 for you. These are the initial configurations, iOS device settings that you learned. Even in chapter 10, router, you can do the same configurations that you did on the switch on the router. Right. Number 2, design and calculation of IPv4 addressing. I think this is the toughest thing you can do CCNA one, subnetting. I think subnetting is a bit tricky. Once you are over that head door, everything else is that easy. Right, configuration of iOS device interfaces, including IPv4 and IPv6. Right, we also have configuration in IPv4 and IPv6 addresses. We'll be doing that. Addressing of network hosts, no problem. Enhancing device security. Right, when you talk of enhancing device security, I think that is chapter 16 for you, CCNA 1. Where we have commands like security min passwords, minimum length. When you are asked to have to command your switch router to have passwords with minimum length of characters, mostly you encounter and meet character 10. Yes, I'm more than 10 characters, my passwords. We have another one which allows router redo. Let me see where the commands are. Commands this normal crema from the head. Let me see, but it allows router redo create a sort of go to sleep mode. Kana risnoshandiswa. If you leave your router idle, rinokwanisa kuloka, if I can say. Router rinoloka. And the command, let me see. Device enhancing. Right. Login block. This one. Login block for 120 attempts. Block virtual login attempts for 120 seconds if there are two failed. No, that's not the one. Two failed login attempts within 30 seconds. That's not the one I'm looking for. Right. This one, it blocks. It's same way as your phone works. You guys, a password did it wrong. Someone has a password did wrong. I think 3 times. Because I wait for 60 seconds. Also try a password again. It's the same thing in a router. All those settings, anonsi, enhancing device, hardening, Cisco hardening devices. Right, I have a lot of things going on. Why? Because time nezoom yedu yamara, it's a factor. Right. So let's get into my configurations edu my configurations are child. Right. Requirements by device, building one router, TSM initial router settings, interface configurations, Twitter SSH. This is also important, very important, SSH. Secure transport for remote configuration connections. We will cover that as well in this. Backup of the configuration file to a TFTP server. We will do that. Second floor switch, enabling basic remote management by telnet. Okay. Then we have addressing from our PCs, NEMA servers. This is our addressing table. We're going to fill in that addressing table before data configurations, edu instructions, step number 1. This is where the real work starts. Right, design an IPv4 addressing scheme and complete the addressing table based on the following requirements. So we have a network, my requirements edu. First thing in the network on my right here, I have to identify how many networks are in that network. So my networks, we have networks of many sizes. My smaller ones, generally, we call them local area networks. Multiple local area networks, they make up wide area networks. Right, in this case, I can see in two my local area networks. This one, the second floor LAN, and this one on my left, the first floor LAN. And this one as a whole, it was a wide area network in its own. So first thing, networks mangani. So if I'm subnetting, it means I only need 2 networks, right? Now, depending on the number of hosts are in each of those networks, that is how I'm going to subnet. So if you went through my videos of subnetting, I think we discussed 2 ways of subnetting. One, going via the number of networks, which usually wastes my addresses, and 2, going via number of hosts. Here, Dr. Dylan going via number of hosts. That is what we call variable length subnetting. Variable length subnetting mask, VLSM. Right. A, we have a network 192.168.1.0. Subnet it to provide 30 host addresses per subnet, whilst wasting the fewest addresses. Right. So we want to subnet our networks. Our network. This is our network. From our ISP 192.168.1.0.24. Right, let me see. Okay, can I do this? Yes. Right. So our network, we have 192.168. Let us subnet first before we do anything else. 192.168.1.0.24. That is the network that we have. Right. We want to subnet to accommodate 30 hosts per subnet. How do we do that? I think from the videos that I shared the IPv4 addressing, I highlighted using what lecturer akandidzidzisa, trainer akandidzidzisa, equal those the magic numbers. So if I want to accommodate 30 more hosts, I think the magic numbers that I need to use is, let me see, is it 2, 4? No, it's not 4, it's 8. Right, it's 8. 32. Okay, let me see, 248. I'm 28, 64, 32. So this is 25, 26, this is 27. Right. If you don't know where I'm coming from, you can always refer back to the videos. So this is the magic numbers that I'm going to use, 8, 32, 27. If I want to accommodate 30 hosts, the magic numbers is 8, 32, 27. So what this means is I'm going to create 8 my subnets. Each subnet is going to have 32 maximum addresses, which we will see it is 30 actually. Right? 30 because one is being used for the network ID and the other one is being used for the broadcast. So 32 minus 2 addresses, 30 maximum addresses, 30 addresses that we can have. Then our subnet mask is /27, which when we are doing our configuration is 255, 255, 255. If 24 is 0, this is 128, 128 plus 64. plus 32. Right, this is 6, 4, 1, 10, 2, 1, 224. So this is 224. This is our subnet mask, 224. Right. What are the networks that we are going to have if we do subnet? The networks that we are going to have, the first one is the same as the parent. 10/27. That's the first network. The second network, we add this number here. The third network, we add 32, 32, 32. From the magic numbers we have, the number in the middle is the one we add to get our networks. So if I have 32, I will have 64, I have 96, etc., etc. So these are the networks that we are going to have. 192.168, 192.168.1, 192.168.1, dot, slash 27, slash 27, slash 27. All right, let me see. Where's my calculator? Where's my phone? All right, 96 plus 32. Those who are quick with math, you can help me, please. 96 plus 32 is 128. Right, 128 plus 32, 160 plus 32, 192. Then we have 224. This is the last network, 224. Right, so these are the networks that we are going to have, 8 networks from 0 up to 224. Then the next thing, we go back to the question. What does the question say? Subnetting that opens up. So what it means, subnetting is very easy. Subnetting and get to my examples, my videos, my notes. They were not complicated, but they were way complicated than these ones. This one that we are doing here. So we've already subnetted the base and my networks here. Right. Assign the fourth subnet to the first floor line. The fourth subnet to the first floor line. Right. I can come back here. So the first subnet to the fourth subnet. So if this is my first subnet, subnet number 1, this is 2, 3, this is 4. So I assign this to the first floor line. Right. So first floor line is 192.168.196.27. And the first address, right? Very important. First address is dot 97, and my last address is dot. I always look at this next network, 128. 127 is my broadcast, 126. So dot 126 is my last address. These are the range of addresses that I'm going to use in the first floor line. Right. Let's go back. All right, if I go back, then assign the last network host address in this subnet to the G00 interface. All right, trip up, let's now create our table. Right, let me see. Let's now create our IP addressing table. All right, so addressing table here, we have a router building 1, remember interface G00, G01. I think there's a serial interface as well. We have switch 1, we have switch 2. Let's say we have PC1, PC2, PC3, PC4. First floor line, first line, let's just call it first line. It's 192.168. Is it 196? Right. Slash 27, which is 224. Right. Let's fill in addressing table here. So assign the last network host address in this subnet to the G00 interface. So G00 interface to first floor line is the last network host address. Last network host address we have already seen 3097 do first. Last 30, let me see, last is 126. So last is 126. Dr. G00 interface 168.1.126 do G00 interface address. Dozoka. What's next? Let me see. Starting with the fifth subnet. Subnet the network again so that the new subnets will provide 14 host addresses per subnet whilst wasting the first addresses. Right, so I'm taking the fifth subnet. I'm going back. I'm taking the fifth subnet. This is my fifth subnet, this one with 128. I'm going to subnet it again so that I have 14 host addresses. Right, so if I take the fifth subnet, let me see. Let me go here. Fifth subnet is 192.168.1.128/27. If I subnet it to accommodate 14 addresses, my magic number is going to be 16/28. Right? Meaning I'm going to have 16 networks, each with 16 minus 2, 14 addresses, and my subnet mask will be /28. That's my prefix length. Right, so the first network that I'm going to have here is 192.168 is the same as the parent 128. The difference is the mask. Instead of 27, we now have 28. The second network I'm going to have, I add 16, 128 plus 16, I think is 144. 144 plus 16 is 160. I'm not going to go all the way. I think this will be enough to answer my question. So these are the networks that I'm going to have after subnetting a subnet again. All right, going back to my questions, I've already subnetted. Assign the second of these new 14 host subnets to the second floor line. Right, I take the second one. If this is the first, this one is the second. So the second 144/28. I go back to my networks. All right. So the second here is 192.168.1.1.144/28. This is the second floor LAN. The first address in this is .145. The last address, if I want the last address, I always look at the next network. 144, the next network is 160. It means 159 is the broadcast, 158 is the last. So if this is the first, this is the last. Back to my question, subnetting. If you are done with subnetting in CCNA1, you are done with everything. Assign the second, we are done that. F, assign the last network in this second floor LAN to the G01 interface of building 1. So the last address, 158, we assign it to the G01 interface, 168.1.158. So this one is /28, this one is /27. Then we have the serial interface. Let's see what's the address. No, we don't have the serial interface. Why did I put it there? Our router, it only has 2 interfaces. All right, let me see. Okay, our router, it only has 2 interfaces. Then we have the link long cow. Okay, that's why IPv6. Okay, this network is pretty simple. We don't have a serial interface. So let me remove this one. We don't need this. We are done. Right. Let's continue with our instructions. Let me see. We were at F. Step 1, F, G. We are done with G. Then H. Configure addresses on the hosts using any of the remaining addresses in their respective subnets. I didn't see anything to do with the switch. Okay, G. Assign the second to the last address in this subnet to the VLAN 1 interface of the second floor switch. All right, so second floor switch, second from last address. Second floor switch, let this be our second floor switch, second from last address, right, in the second floor line. Second floor line, last address is 158. Second from last address, 192.168.1.157/28. All right, let me see the first floor switch. Where is the instruction for the first floor switch? Assign the fourth subnet, assign the last, starting with the fifth. I don't see the other one. Okay, the other one is not there. Probably it's already configured, the first floor switch. Done. Step number 2, configure the building 1 router, configure the second floor switch, configure host addressing. Right, once we are done subnetting, let's fill in the our addressing scheme. So this one we are not going to configure, it's probably configured. Then for the PCs, they said choose any in the network. So let me see, PC 1 and 2, which ones are in the same network? So host 1 and 2 are in first floor. Host 1 and 2 are in first floor. This is my first floor network from 97. So let's take 100, 192.168.1.100/27, then .101/27. Those are my two PCs. Then this one is a server. Then we have PC3 there in the other network. So in the /28, from 144, let's take 150. So let's take PC3.150. Our server, let's take .151/28/28. Done. We're done with our subnetting. All right. Step 2, configure building one router. Configure building around one router with all initial configurations that you have learned in this course so far, starting with the host name. Right. For my assessment, ukauya ukaclicka router, mostly kana makuziva stereo, hamuchaisi console pamarouters. You can go directly click pamarouters, then you access CLI, the command line interface with our configurations. But from assessment, you need console. So the first thing we are going to do console yedu bar so that we can get access to our router. All right, there we go. Terminal, okay, there is our router. First thing we're asked to do, change the name to Mido. Is this not moving? All right, change the host name to Mido. So we enable configure terminal host name Mido. Right, done. Protect device configurations from unauthorized access with the encrypted privilege exec. Privilege exec,
Amakerera hapo
that is enable secrets. That is it.
apa kanzi host middle
Yeah,
host name
right,
pakafanira kuti host name.
right. Yeah, ini ndoshandisa mashortcut.
Alright.
Mukanyatsoverenga chapter 2 yenyu zvakanaka, you see kuti mashortcut all the way. Mashortcuts, you need to know mashortcuts anofanira kushandisa so that basa rako rinoita much faster and much more efficient, time efficient. Right, enable secret. What's the password yakaiswa? Hapana password yakaiswa. I'm going to have HHP as my password. Right, what am I saying? Password is too short. Must be at least 10 characters. So let's have HHP 1, 2, 3, 4. No, 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 no. What am I doing? Right, enable secret. Right. HHP 1, 2, 3, 4, 5, 6. Those are 10 characters. Must be at least 10 characters. Why is this one not working? Enable secret. All right. Let's have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 10 characters. A zero is not characters. They should be characters. Right. Let me go back to issue my shortcuts here. This is Control C. You know, it's also knock. Can I do not exit? I can say EX. Exit. That's exit. Panapa instead of enable, I can say en. That's enable. Once we do it, and is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right. Instead of configure terminal, I can say config T. Those are shortcuts. So it's the same thing, generate up a host name. You don't have to write everything. How do you know kuti unonyora shortcut yakaita sei kuti command yako ishande? This is what I used to do. If I type H and I say type, ikakompleta yega like this, it means H is a valid shortcut. So I can say H, ndobva ndachinja middle yangu ikuita R1, inofanira kubva machinja. You can see R1 yatochinja. Zvireva kuti H kana uri global configuration is the shortcut for host name. Pandatonyora host apo ndatonyora zvakawanda. So next time is just H. Middle. Ndatodzidza zvakawanda ipapo. Middle, right. Let's go. Protect devices from unauthorized access. Enable secret DISA. Secure all access lines. All access lines. Let's go to line VTY first. My virtual terminal lines, my lines and underscore access your device via SSH or Telnet. So ndo atinoda secure, right? Tomesera password. So instead of password, I can say pass. HHP too short again. Right. The reason why password here is too short is because probably munakagadzira library aka pre-configure router redu ne command ye minimum characters. So minimum characters akaisa 10. So izvezvi you won't be able kuisa password in less than 10 characters. That is what is happening here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see if that same password. Right, after this, without login, that will not work. Right, we are done. Let's have another one, align console, 0. Right, my VTY data local, my lines and provide access to your device via SSH or Telnet, then access via the console, in game line line console 0. Line console 0 to the password as well. Right. After we're done with that, log in, clap, done. What's next? Secure all access lines in the routers. We've done that. Require newly entered passwords must have a minimum length of 10 characters. Iyo command yangeka kudhara. I think the command itself is security. Let me see if I know the security, right? Mean, no, security password, mean length, right? 10. That's the command irape. Yangeka kudhara. I think ndini ndakaisa ndakasevha lab, I don't know. Right? We've done that. Prevent all passwords from being viewed in clear text. What are we doing? That is encryption, service password encryption. If I go and say show run, let me see. If I show my running configurations, the reason why it is a service password encryption is because of this. If I go and show my running configurations, you can see password yangu. It's in clear text, it's visible. The only one is still visible. The other thing that is a secret is already encrypted. This one, enable secret, is encrypted. So every password inoiswa after command ya password is encrypted. But password inoiswa after command ya secret inenge iri encrypted. Right. So for our animal passwords are in clear text, they will need to be encrypted. How do you do that? Service password encryption done. If I then go and show my running configurations again, you see my passwords I'm gonna get encrypted. My keyword asisipo. And this number 7E, it has a meaning. This number 5, pana, it has a meaning. It means gonna pana 5 per password. E password their secret. Gonna pana 7, e password their password. I hope I'm making sense. I had to say that. I just want to, where did I learn that one? Right, let me see. Prevent all passwords from being viewed. We've done that. Configure the router to only accept in-band management connections over the protocol that is more secure than Telnet. Chirungu chakangowanda to mean configure SSH pa router yedu. So how do you configure SSH? If I go back a little bit, we have two more protocols which are used to access our devices remotely. We have Telnet and SSH. Telnet and SSH, they are almost the same. They allow us to access our devices remotely. The only difference between those two, one is less secure than the other. Telnet doesn't have that doesn't have encryption. That doesn't have it sends clear text. Whilst SSH is a bit secure, it encrypts text. So zviro kuti panonge uri kusenda passwords kuti username ndinani, password ndoda kupinda murauta, Telnet it says in clear text, SSH stands in encrypted. Right. How do we configure SSH? The first thing we need to do, if I remember very well, you need to have a host name. Your device need to have a unique host name, right? So ours already have one, middle. You also need to configure let's start with my keys. Ndataura SSH ine encryption. Encryption inoitwa neanonzi makeys. Security. I think I can have another day tichitaura security, not today. So makeys iwayo, I think the command is crypto key RSA, no, generate, crypto key generate RSA. That's the command to configure. How many keys do we want to use? Please define the domain name first. Okay, thank you very much. We need to define the domain name first if we are going to configure SSH. What is the domain name? Domain name www.com. That's a domain name. Let me see. Domain name, IP, domain name. I think that's the correct command. Thank you. IP domain name. So I'm just going to use whp.com. Right. So if you are going to access your switch remotely, you can access using an IP address, or you can have a domain name to access your device, not switch, not only switch. This one is a router to access your device remotely. That's why it's important to have a domain name. Zvoroti kana ndoda kuaccessa device rangu remotely, I can say hhp.com, then rinokwanisa kundidirecta kune device rangu. We'll get there. Right, so after that, domain name ready rapo, then we can generate our keys. Do you really want to replace? Yes, I want to replace. How many bits? Right, we're going to use 1024. I think I was calculating this with Vincent. 1024, it uses 10 bits. So the more bits you use for encryption, the stronger the encryption. Ukashandisa 2 bits for encryption. Zvoroti, if your password irushandisa 2 bits for encryption, it's very weak. Ukashandisa 5, 6, 8, 10, it means inenge is stronger. The more bits you use, the stronger it is. So here we are using 10 bits. That's why we have 1024 key strength. That's 2 to the power of 10 number up. 1024 done. After that, you create a username. So when we talk of security in a SSH, in a encryption, yataisa pa encryption key hapo, in a authentication as well. So munhu wese apinda aita access to the device, anofanira authenticate kuti ndiwani and what's your password. That's why it is more secure. Authentication, encryption, and authentication. In this case, our username is netadmin. Let's see that one. We are now here, right here. So our password is netadmin. Then here we can know our username is netadmin. Here we can use secret or a password. You can use password or a secret. Pakuisa password up. 2 ways you use my password: secret or a password. Because a secret is already encrypted. Because a password, then I'll need service encryption could encrypt. So it's just safe to use secret because password they're going to be encrypted already. The reason why it's singaishandise pakuisa pama lines up is because hapana secret yacho command pama lines pangori password. Right, secret, what's our password? It's Cisco underscore CCNA 5. Is correct. Cisco, yes, underscore CCNA 5. Give the user the highest administrative privileges. Highest administrative privileges, I think there's a command after that. No, there should be a command after this one. Enable admin, after net admin, let me see. No, there should be a command here. EMA privileges, let me see. Right, privilege, there it is. right? Highest administrative privilege. What's the number here highest? Okay, my privileges, air administrative privilege is 0 to 15. So I can see the highest is 15. Then after that, I can have my secret. Yeah, secrets score underscore CCNA 5. So that's my username, right? I think everything is right up. It's in chapter 16. Username ready done. After that, you have to go to my lines. Number two, my lines, VTY, dogonaona access here, SSH. So you need to activate those lines. Kuti akwanise activate SSH. So we go to those lines, line VTY. Let's activate all of them, 0 to 15. And the command transport input SSH. That's the command to activate SSH here to my lines. Then we have login local authentication. This one do for authentication class. SSH here they have. If I go to my show commands, I can see in the less than 1 minute. Let me end here. If this one ends, you know the deal. You can always join the same link again. So my show commands here, we can see your SSH boy, right? SSH Apple. Where is our username? Domain name redo rapo. Always use my show commands to verify or configure. Username redo rapo. What else? I think that's it. Let's end this one and we continue Tapa step 2 part B.